We're coming to our final technical presentation before we finish the day with the podium discussion. And I'd like to welcome Juha Kokon. Juha?
Schönen guten Abend. Thank you, Peter.
Juha is located in Helsinki. He is the CEO of Canado. I wouldn't call it startup. I think you're already beyond startup. Yeah, a Finnish company now on the market for a couple of years. For on the one hand, three-dimensional switching devices. On the other hand, for something interesting which has to do more with heating and heating technologies. And although it's not maybe 100% fit to the electric vehicle session, we think it's a technology which has a great bandwidth of where to get introduced and where to get used. I know Juha has also a Nokia background. Many people in Finland have a Nokia background, and I learned that it's either in networks or in mobiles, so you can comment on this one. And the stage is yours, Juha.
Excellent. Thank you, Peter, and thank you for this opportunity here. I think that we have today heard great news coming actually from the another industry, from Pfizer, announcing this COVID-19 vaccine. And so I think that this is absolutely excellent news for automotive industry as well. So what I'm going to talk today is about 3D formable heaters, especially for ADAS technology. So if you click to the first slide, or actually the second slide, thank you. So if you look at this autonomous driving technology and especially the active safety there, so we do see that number of the vehicles that are having active safety functionalities are increasing, and in some cases pretty rapidly. Also, what we do see at the same time that sensors are getting more and more sophisticated, whether they are camera sensors having more fisheye view, better resolution there. Some cases also LiDAR technologies included and integrated, as well as the radar technology. At the same time as number of the vehicles are increasing, we do see that the level and capability of this technology is increasing. So level 2 is getting to 12, level 2 plus, as well as to level 3, and some small scale also do the kind of the 4 and 5, but primarily level 2 and 3. And of course, from the company who is making the sensors and heaters for the ADAS technology, it is that it is going more sophisticated and more money is getting into this one is very important thing. And we know that all the major players are now following Tesla there, BMW, Daimler, Volkswagen Group, Toyota, and so on, and some new players as well. So this is getting more and more important, as we have been hearing today already in a number of the presentations. So if we move the next slide. So this technology, next slide please. So if you look at what is the industry challenge here, so these sensors are working nicely in perfect day in California. But what if there is a high humidity, for example, in Singapore or Miami, and you have a fog in front of those sensors? Or what is getting right now more and more relevant in Bavaria, as well as here in Finland or Michigan, is that you start to have their ice and snow in front of those sensors. So, and there might be in some cases also rain. So you need to get rid of that snow, frost, fog, and rain in front of your sensors, that they are truly working. Second challenge is even with these headlamps, LED headlamps, that this conventional technology created heat, but these LED headlamps don't, which is a great thing. But you might have, especially with commercial vehicles, the challenge that they are getting frozen, and that is limiting especially the performance of those lights. So you need to get rid of that snow. Next slide, please. So where you can apply this technology, like the sensors, typical most probable place is what we do see here is in windshield, where you have a rear mirror, or you might have it integrating to the bumpers, to the emblems, to the backside. They can be even integrated to your rooftop, mirrors, and so on. So there's a lot of different type of integration happening for the various technologies where radars are typically low on the place and camera you need to see very wide angles like in LiDAR case. So if you go to next slide. So very shortly about the Canado. What is the Canado? Next slide, please. So very shortly about the Canado. So we are like Peter mentioned, we are not anymore like a startup company. So we have been delivering our sensors for the automotive industry already almost for 5 years. Initially with the smaller volumes and nowadays more and more bigger volumes there. So we have been delivering already over 500,000 sensors. And where we are really proud of is that our field return rate is still like 0. Also, what we did is that we made a major licensing deal with Denso, and we have been building the manufacturing capabilities for them. This is absolutely non-exclusive deal there. So this technology is based on the Helsinki University of Technology. It's called Aalto University, where we have created very strong patent portfolio. So fundamentally, Canado is a material company. So we have patents for the material itself, carbon nanoparts. We have manufacturing patents there, as well as application-related patents. And this technology, these concepts have been winning various type of awards recently. So it can be either HMI design, cockpit design, like the ID design, material, brand, and so on. Especially, and even at CES, it won the Innovation Award. So if we go to next slide. So we are a material company, so we have been primarily working with automotive industry. So having the solutions like for ADAS heaters, as well as 3D touch for the cockpits. But this material is also applied for the semiconductor industries, because this can create like a spider network without any substrate there. And it's very exciting applications where we are, for example, enabling the 7 nanometer technology and below to happen in semiconductor industry. So this is just an example that we are not like a application company as such, but this material can be used for the various type of applications. Next slide. So these automotive solutions, what we are talking are like, they can be the windshield heaters. The heaters can be applied to the emblems, like in this case, to the headlamps, even for the comfort capabilities for interiors. So when you have especially translucent material there, so it can be combined with textile and leather as well. Next slide. So this development where you are building totally new film-based heating elements and having this 3-dimensional shape cannot be done only with Canado. But we have been working with many industry leaders to developing the related technologies. For example, you need to have adhesives that are working with 3-dimensional shapes and can apply with forming as well as molding. Similar things comes to the silvers and many other technologies like touch ICs. So this is like not only that one company can do this work, it requires that the whole industry, whole technology industry comes together and make jointly a solution. And this is what we have done with the companies who have been listed here. Next slide. So our vision is that this heating, autonomous driving can happen with any weather. It's not limited to the perfect weather in California. So if you go to next slide, so what is then the benefit what the Canado's film-based CNP heater is providing there? So firstly, what is important to understand that the single carbon nanotube is like 2 nanometer thick. So it's 1,000,000 times thinner than a single paper sheet. So it's super tiny thin. And one tube is like a couple of micrometers long. And it's a network, like a spider network of those tubes. So therefore, these tubes are super conductive and conductive for heating as well. So therefore, you can provide totally even wireless heating there, and what is very important, without optical distortion. I'm going to tell a little bit more about that one because it's very important. Also, it's providing very high transparency there, but this can be combined not only with glass and plastic like PC, but it can be combined like fabric material like I was discussing there. One super important feature there is that it can be also 3D formable. So it can create the shape you like. And this comes from the technical functionality that this CNP network is like spoiled spaghetti, which you can actually stretch up to 200%. And therefore, you can create basically any structures without losing the conductivity and thermal conductivity functionalities. And it can be bended with 1 millimeter radius. This helps you to create the next one that you can have a direct surface integration for your heaters so that you are really heating the area that is absolutely needed to heat and not like the ambient environment there. What is also critical in this environment, and automotive industry is very famous of having the really tough reliability requirements. And we have been also working heavily on that one. And especially now when we are talking about heating elements that are in windshield, can be in very sunny environment in California where sun is heating that heavily. So it has to have very good thermal and also like humidity capabilities. And we can go to the next slide. So what is the challenge currently where mostly these metallic wires are used for the heating elements? So you can see here, even in this picture, that it is causing pixel-to-pixel distortion. And now as we are heading to the level 2 plus, level 3, cameras are getting more sophisticated, angles are getting wider, your windshield angle is also wider there. So that creates that image, it's not accurately seen there. The object detection comes very critical because you are not anymore seeing only that, hey, what is the speed limit? Is it 6 or 8? But you need to see way more accurately what is the object, what is the character there. And this is safety functionality, not anymore like comfort functionality. So if we go to next one, and now I'm going to a little bit detailed level, but I think that this is important. It's important that now when you have these cameras, like I was discussing with the more resolution, wider angles, and you need to have really accurate object recognition there. So if you have their wired heater in front of the camera, that is creating pixel-to-pixel distortion, and you don't see your object that well. Therefore, what can be done there is that you have a film-based heater with these magical tiny CNP tubes that are providing really low haze and really low distortion. So you see on right bottom corner the example, so where you have a glass only, and you see these stripes like black and gray stripes. And what is very important that the edges of these stripes are very, very accurate. So it's like the histogram that you know that this black ends here and immediately starts to gray. And here you can see how the solution with CNP can provide super good, excellent, it's called like MTF. So it shows the minimal effect of the image distortion. Similarly, when we go to next slide and we look at the LiDAR there, so in LiDAR case, in LiDAR you are actually measuring distance. In camera you want to see the object. Could you go to next slide, please? So here, when it comes to ADAS, you want to, and ADAS LiDAR heater, you are really measuring the distance there. And when you are investing in reasonably expensive LiDAR technology, of course you want to make very, very accurate distance measuring. And if your surface has these metallic heaters or something that makes it's called wavefront, having their inaccuracy there, or ununiformity there, that creates the structure that actually your LiDAR is not anymore very accurate. So it's making a significant investment in the LiDAR, putting heating element on front of that one and losing the accuracy. That's not the good formula. So therefore, what we are providing here is that having, again, the film-based, CNP-based solution that makes it very, very good. It's called micro rod, so that you get the extremely good RMS there and low interference there. And what is also great that this CNP heater works well with both 900 nanometer as well as 1550 nanometer technologies there. So if you go to next slide, like was talking about the reliability. So reliability in automotive industry is very, very critical element. And we have been working together with our partners, with Japanese industries, meeting the really tough requirements, whether it's a very high temperatures or low temperatures, or combining high temperature as well as the high humidity there, and for a very, very long time. So this was the very important development, what was done with our material to be capable of meeting the toughest requirements in the automotive industry. Let's go to the next one. So then you can have a various type of integration. So the one is that you are integrating your heater to the windshield, where you have to actually integrate it between the PVP layers, like the sandwich structure. So you have a top glass, you have a bottom glass, you have a PVP layer there that is making your display unbreakable and having the excellent also from the audio and noise reduction perspective, and having the kind of the heater there in between. Then you might combine only with the one glass there on the bottom side of that one, or in some cases where you really want to have a 3D shape, like in emblem or headlamps, it can be something that you are thermoforming is the CNP material with the substrate, and then either 3D laminating or injection molding that to be very, very robust structure there. And in some cases, you can have this comfort interior heater, especially combined with translucent material. We can go to next slide. So all in all, we know the challenges where we started are that autonomous driving, these active safety features have to work with any weather. Providing the safety, providing the comfort needed there. And what can this magical CNP material provide as a solution there is that it's providing the additional safety so that it will work with any weather. It can also provide excellent clarity, as we do know when we go to cameras, when we go to LiDARs there, you need to have super good accuracy there. And as we go to the new levels like level 3, where car is taking partially the control in the certain environments, you need to have a better sensors. The overall system has to work better than what it does earlier. And having the efficiency there, so like we were talking about, the CNP tiny network is providing even heating, not heating like wires there, but having the even heating there. That mean, and also having the integration with surface itself, that you are losing as little power as possible, because EV cars, like we know from this conference as well, are coming, and you need to save as much battery as possible. So Peter, with that one, I would like to close my presentation, and I'm looking forward any questions you may have.
Okay, thank you very much. Very good. Yeah. Some people might ask, why are you part of this electric vehicle session? And I think your business now around for a couple of years, and it turned out that your first customers on some applications is really the ones Dr. Fetzer, for example, showed earlier today, which are in electrification and started with electric vehicles. Now with your experience and having a lot of interaction, do you think they are more innovative, or it's because they start from scratch and they're more open to talk to new companies or new ideas, or what is some of your rationale why this is more with new players than, let's say, with the so-called existing players?
Yeah, I think that's excellent question. So what I do see, maybe a couple of things there. So these new EV cars that are, quite many of them are our customers, product development time is shorter than maybe with traditional players there. I know that one from my Nokia background. So when Android operating system came there and the Chinese vendors came, suddenly they were developing their smartphones half in the time what we did. So these new challenger players, they are ready to make these development cycles faster. Second, what I do see there that I think that they have slightly higher capability of taking risks. I think that the first company who took our technology there in place, I think they took certain level of the risks, because we were first time producing sensors for automotive industry. Are they reliable? Can we deliver reliable? Will there be some problems on the field? But I think we have demonstrated of delivering extremely constant manner and with no field return. So I think that it is about there are 2 points here. It's about the development cycle being the faster, as well as those newcomers, as they are newcomers as well, they have slightly better capability of taking risks.
And staying a little bit with those who primarily develop cars, electric vehicles, and your interaction, it looks to me like the traditional automotive OEMs and supply chain is, as you said, is a little bit more conservative when it comes to new technologies and risk-taking, yeah? And also that those who do electric vehicles have automatically a greater symbiosis towards ADAS, yeah, going forward to level 3, yeah, where we heard today that a lot of others are more reluctant and talk about 2+. Is that also your sense that this combination of electrification and, let's say, autonomous and semi-autonomous driving has a greater relation?
Yes, I think that it's not like that every vendor who is having EV cars are also advanced when it comes to active safety or autonomous driving. So there are, I think that when it comes to China, they are not necessarily that advanced, for example, compared to players in USA. Mm-hmm. However, many Chinese players are active when it comes to electrification. Then, so that's maybe the one part of the answer. What was, Peter, your second point? Sorry, I missed that one.
That's fine. The question is almost answered, and we have the first 2 from the auditorium. Yeah, we made it well. Yeah, Mr. Fujimoto is asking, your Canado recently have announced that you have developed 3D shaped touch switch in your door trim. In not autonomous level 3 or 4 vehicles, but in general cars, are there any possibilities for the 3D touch HMI in the door trim to deploy into them?
Yes, so of course, when we are talking about door trim, I think that we are talking about now interiors, and we are talking about 3D touch functionalities. That is the another product line. So we have another product line that is doing these heaters, and another thing what we are doing is 3-dimensionally shaped capacitive touch. So this 3-dimensional shaped capacitive touch technology can be applied in front of the displays, like what we have done with, for example, together with Continental, having this 3D surface display product. Then it can be applied with the sensors, like we introduced this door trim with one of our partners, with TS Tech. You may have noticed that one. We have also done, for example, like Orico steering wheel as a concept example, where you have three-dimensionally shaped sensors integrated into steering wheel, where you can operate that one with your thumbs. And why thumbs? That's the way, how do we operate in today's world, also smartphones. So that instead of using your index finger and trying to touch some display that might be far away and distracting your driving experience, what we are bringing is that bringing these three-dimensional shaped capacitive touch sensors to the steering wheel, and therefore having a couple of things. So you can operate them with your thumbs. That it's your nowadays, based on the evolution, the normal way of operating with touchscreens, as well as you can keep your hand all the time on the steering wheel, so providing the additional safety there, as well as being also comfort that you don't need to go and try to touch somewhere further away.
Yeah, perfect. David Pony is asking, what is the process needed to form the CNT network to the selected substrate? What kind of equipment is necessary?
Yeah, so this is excellent question. So what do we do have? So we have our totally automated production lines. So we have, like, we are calling them reactors, where we create these carbon nanotubes. And these carbon nanotubes are coming to the substrate, and we have roll-to-roll line. So it's in simple manner, it's like printing. It's printing technology. So we are printing our carbon nanotubes to the substrate that is in roll-to-roll format. And then you can, of course, cut it and make heaters or touch sensors or whatsoever you like based on that material.
Very good.
And now I put it slightly simplified way.
Yeah. Okay. Excellent. Yeah. So thank you very much, Juha. Yeah. Stay tuned for the podium discussion. It will be. We will have some very senior industry leaders in semiconductor automotive industry with us. And hello to Finland, and see you soon. Thank you.
Thank you.